What's up, guys? So, we all know that APIs, when dealing with APIs, clients will call servers through some kind of communication. What is that communication exactly? What's happening under the hood? What's going on there? Let's get into it. So, here we're going to be talking about the narrow waist of the internet. So, the internet opts for a layered approach to its architecture to manage the complexity of sending data across two different entities. The internet standardized the IP as the middleware around which all the innovation happens. Most public facing API calls use HTTP today. If we use a raw IP packet with our custom transmission protocol, something other than TCP or UDP, it won't make it very far. Enterprises today use firewalls that'll drop everything else. Anything that's not TCP or UDP will get dropped. So, why do most API calls converge to using REST over HTTP? This will be a question that we'll answer in this video. So, let's talk about layered architecture. Say we have an M layered architecture where each layer has a specific function. The nth layer in the M layered architecture provides services to the nth minus 1 layer and gets services from the nth plus 1 layer. Such a layered architecture has the following advantages. It provides modularity so each layer can perform its own operations. It provides ease in troubleshooting the network. It makes modification in one layer have no impact on another layer. And there's flexibility in accommodating different types of applications. It divides the large task into smaller tasks and it makes it easy to solve the bigger problem. So, to communicate between any two systems sharing a network, the request is communicated from one layer to the next, where each layer performs its own set of tasks. So, an interface is used to create the link between the layers and determine which services are available to the upper layer by the lower layer. Each layer has at least one protocol that determines the following information: the order of the messages over the network, the actions that we perform on the message transmission, the structure of the messages, the messages receipt, error detection and correction. And we have to understand the standard systems used worldwide to ensure communication and interoperability. And we'll discuss the models that were followed to structure the internet as we know it today. So we'll talk about the OSI model, and then we'll talk about the TCP IP model. So let's talk about the OSI model. So, Open System Interconnection (OSI) consists of 7 layers, each with a header containing information about the protocol in use, addresses, sequence numbers, and so on. So, let's talk about this first layer here, the application layer. The sender interacts with the application layer, and it includes different protocols, for example, HTTP and SMTP. And then let's talk about the next layer. In the next layer, we have the presentation layer. It takes care of the data's format on the sender and receiver side. It ensures that the data is understandable at the receiver's end. It also may perform encryption, decryption, and compression of the data. So we have this presentation layer both on the sender and the receiver side. Then we have the session layer. It creates, manages, and terminates the sessions between end-to-end devices. It's also responsible for authentication and reconnections. So next we'll get into the transport layer. It's responsible for data ordering, reliability, and error checking. And you should also note that the application layer, the presentation layer, session layer, and the transport layers are only present on the end nodes. and not on the intermediate nodes, so not on routers. And then let's talk about the network layer. The network layer has IP addressing and routing as its responsibility, and a node connected to the internet needs to have an IP address for communication with other nodes. And then we have the data link layer. This is responsible for frame transmission, address for local area network, and logical link control. In OSI models, the data unit considered to be a packet for the network layer. So a network layer will use a packet, and a frame is our unit in the data link layer. And then we'll get to our physical layer. It handles the transmission of bit streams on the physical link between the sender and the immediate next hop receiver. So the physical link can be either an Ethernet, a DSL, etc. So the OSI model is always considered as a reference model and is not implemented because of many technical and non-technical reasons. TCP does not contain the session, presentation, or the physical layer. And the contribution of the OSI model was a clear separation of concerns into different layers and their service interfaces. OSI was lacking in terms of protocols, and that's where TCP/IP came in. So let's talk about that model. The Transmission Control Protocol, Internet Protocol, TCP/IP model was mainly based on Internet protocols IP and TCP, and the collection of protocols creates an hourglass shape, and the Internet protocol uses the IP layer as its narrow waist. So protocols above it and underneath can flourish independently. We can add new protocols related to application, transport, and network layers of the architecture according to the application's requirements. Each layer performs particular services and communicates with its upper and lower layers. Physical and data link layers are combined in the network access layer, right? So in the OSI model, the physical and the data link layers are now combined in our network access layer. And it consists of multiple networking technologies such as Ethernet. And the internet layer is responsible for the logical data transmission over the network. The transport layer determines the application using the port number and sends the data to the relevant application on the remote peer, right? And the application layer uses multiple protocols, HTTP, SMTP, FTP, etc., to interpret and display the data on the screen. So one thing that's different between this and the OSI model is that the physical data link layers are combined. So if you go back, we can see we have our data link layer, our physical layer, which are combined in this one. So in this model, the network access layer combines these two layers right here. So let's talk about the narrow waist of the internet. The Internet Protocol, IP, has dominated the network layer. And this is because it maximizes interoperability, it makes addressing universal, provides best effort service. The internet has a narrow waist architecture because IP extends its support to many upper layer transport and application protocols and many bottom layer communication technologies. However, the internet's progression in multiple aspects, such as real-time responsiveness, security, and so on, coupled with the explosive growth of HTTP-based applications, led to the logical conclusion that HTTP is the new narrow waist of the internet. So HTTP easily penetrates enterprise firewalls, it has streaming, so it's now the new narrow waist of the internet. And businesses depend on HTTP to exchange data, and majority of traffic on the web runs over HTTP. It's super important due to its content-centric and versatile nature, and it's the engine to run REST APIs. And HTTP requires TCP for transmission and TLS for security. So, in summary, the original internet designers wanted the IP layer to be a thin middleware enabling independent innovations above and below the IP layer, though today, many public-facing APIs tunnel through HTTP for these reasons, and HTTP is one of the few applications enterprises will allow on their network, and because of a complementary ecosystem that's evolved around HTTP, over time it's become the new narrow waist of the internet. So let's do a quiz. Which protocols are used for the transport layer? Well, one thing that we learned in this video is that IP used to be the narrow waist of the internet, and so the answer is C, TCP and UDP. So the answer is C. Which layer transfers data using bits as the basic unit? So if you go back to the OSI model, you'll learn that the physical layer is the bottommost layer, and it'll transport data using bits. And the answer is D. And which layer in the TCP IP model performs the functionality of the OSI's data link layer? So if you go back in the OSI section, you'll see that the data link layer and the physical layer are combined into the network access layer for TCP and IP, right? So the answer is B. And which transport protocol is reliable? And for this, the answer is A. TCP is definitely more reliable than UDP. And which protocol is the new narrow waist of the modern internet? So we talked about this. IP used to be the narrow waist of the internet, but as things have changed, HTTP is now the new narrow waist of the internet, so the answer is B. So hopefully you learned something. Leave a like, a comment, subscribe. Let me know what your thoughts are. Thanks for watching.